All right. Okay. So let me make this on higher differentiations, right? Higher derivatives. So now let's say we are being asked to find the okay. We are being asked to find the square y over the x square of all these expressions, right? So now for the first one, we had y is equal to x raised to the power of n, and this gave us the derivative gave us n x raised to the power n minus 1, right? So now we could be asked to find the square y over the x square. Now that could be written as y this, or it's written as the square y over the x square, or it's written as this, right? It's written as this, so it could be any of them. So now whichever way it is written, so we have this higher differentiation, like the square y over the x square, now just means that we're going to differentiate it twice the second time. So we're going to be having n minus 1 multiplied by n multiplied by x raised to power n minus 1 minus 1. Very simple. So here we'll be having n square minus n. I'm putting this in bracket, right? Because if you do not put it in bracket and then you put the x next to this n, then you are wrong, because that means that just this n is multiplying x instead of everything in bracket, because it's everything in this bracket that multiplies x and not just this n. So we have x here raised to power n minus 1 minus 1, that will give us minus 2, and this is the y over x square, right? The square y over the x square. Now they could also take it up a notch and ask you to find the d raised to power 4y over dx raised to power 4. So this one just means that you should differentiate it 4 times. Very, very simple. So I'm going to use question 4 to illustrate this one. So the number that you are being given will determine where you will stop, right? So now for this one, for number 4, where we have v is equal to 5 raised to power 4, 5x raised to power 4 minus 2x minus 7, right? We're having this. So they're asking us to find the raised to power 4v over d x raised to power 4. So very simple. We're going to first differentiate it the first time. So we have v prime, that will be equal to 20x raised to power 3 minus 2. If you don't understand how we got this, go and watch the first video on basic differentiation. Then we have the second derivative. So for this one now, it's just going to be 3 times 20, right? So 3 times 20 x raised to power 3 minus 1. So this is going to be 60x squared. Then we're going to find the third derivative. This one is d cube y over dx cube. This one is d square y over dx square. And this one is just dy over dx. So this is basically what higher differentiation means, or higher derivative. This is basically what it just means. The power will tell you how many times you are going to differentiate it. So let's go. So we're differentiating 60x squared now. So differentiating this, we're just going to have 60 times 2x raised to power 2 minus 1. 60 times 2 gives us 120. So this is x raised to the power of 1. So now we're going to be having the last one, d raised to the power of 4y over dx raised to the power of 4, right? So this one will just give us 120 times 1. Then we have x raised to the power 1 minus 1, which is 0. So this is going to be our final answer, 120. So question can come like this. And then they could say you find d raised to the power 5 over dx raised to the power 5. So this is going to be equal to 0, right? Whenever a function does not have a constant, does not have an alphabet, right? Does not have, like, here we're doing the derivative of y with respect to x. Now if this one does not have x, right, it's just going to be equal to 0. So let's say we have something like this. Now let's say we have something like this: v is equal to 5x raised to the power 4 minus 2y, right? And they ask us to find dv dx, right? This one is under partial differentiation. It's under partial differentiation, but let me just explain it quickly here, in case I'm not able to touch partial differentiation later on. Right, okay, let me just do it here. So we have dv over dx, and we are asked to find for this value here 5x raised to the power 4 minus 2y. Remember, this is you are differentiating v with respect to x, right? So meaning that any value that does not have x here automatically becomes 0. It does not matter what that value is. Even if that value is y raised to the power 100, it's going to become 0 because it does not have x. But if there is x here, everything changes. But the moment it does not have x, it becomes 0. So if we are differentiating this now, it's just going to be 20x raised to the power 3. That's all. This one does not have x, so it means that this automatically is equal to 0. So now let's try this one now. We have v is equal to 5x raised to power 4 minus xy raised to power 100, right? So this one is just going to be v. We are taking this y as a constant. That is what we are taking it as a constant, because it does not have x. Anything that is with x becomes a constant, right? So this one now, we are assuming that it is x raised to power 0, so this is a constant. So if we should differentiate this, it's going to be 0 times this. Everything will just turn to 0, and then we have 0 for this expression. So for this one now, we have x here, right? But this y is going to be a constant, because we are not differentiating with respect to y, but we are differentiating with respect to x. So we are having the v over the x to be equal to 20x cubed. Then we are having minus y raised to power 100. Why? Because this x now is raised to power 1, right? So we are having 1. Let me do it here. So we're having 1 multiplied by what? By y raised to power 100, then times our x raised to power 1 minus 1. 1 minus 1 will give us 0. X raised to power 0 is 1. So we have 1 times y raised to power 100 times 1. This is y raised to power 100. That's why we have it here, right? So now the question could also come like this, right? It's not every time that is the y dx. We could have the x the y, depending on the question. So always look at what the question is asking you to do. So now let's say we have v is equal to 5x squared minus x y raised to power 100. Now this question now, they're asking us to find the v dy. This one now, this means we are finding v with respect to y. So that means anything that does not have y automatically becomes 0. This one here is going to become 0. We have proved it in the past. We don't need to prove it again. This one becomes 0. Then we have minus. Here now we are varying with respect to y, right? So meaning that anything with y is a constant. So this x becomes a constant. So now we have 100 here. So that will be 100 multiplied by the constant, which is x, multiplied by y raised to power 100 minus 1, right? So this will be 0 minus, so that will be equal to minus 100x y raised to power 99. Chicken, now very, very simple. Then if it comes to higher derivative, where we have d square v over dy square, it is going to be, we're going to differentiate it again. So we have 99 times minus 100 x, this is a constant, don't forget. Then we have times y raised to power 99 minus 1, and this is going to be equal to this is going to be minus 9900x. Then we have y raised to power 98, and this is our final answer.